Angles of quadrilateral ratio 3, 10, 7, and 4. That ratio right there is going to let me set up the equation. Since it's quadrilateral, that means the angles add up to 360. So I know 360 is equal to 3x plus 10x plus 7x plus 4x. When I add those x's together, we get 10, 20, 24, so 360 is equal to 24x. Go over here, 360 divided by 24 is 15. And so that means x equals 15. That's not my answer, but that's a good way to get the answer. This is asking for the smallest exterior angle. The smallest exterior angle is going to be supplementary with the largest interior angle. Right there, that's my smallest my largest interior angle. So 10 times 15, or 150 is my interior angle, which means my exterior angle, the smallest, is 30. Problem number 2, again, we have a quadrilateral, which means the angles need to add up to 360. That's the one I don't know. We'll call that one x. And so we end up with 47 plus 165 plus 27 plus x equals 360. So 47 plus 165 plus 27 is 239. I'm going to subtract that from 360, and we end up with 121. So x equals 121. I'm standing directly in front, sorry. And finally, number 3, is it possible to have an exterior angle measure of 16.5 for a regular polygon? Explain. The regular polygon means every exterior angle would be the same size. And so I would need to take that 16.5, multiply it by the number of sides, and it should equal exactly 360, because exterior angles of a polygon add up to 360 triangles. And so I'm going to see if I can divide 360 by 16.5, and I can, but it's not even, so that means that I cannot have a regular polygon with 21.8 sides. So the answer is no. Because 16.5 does not go into 360 evenly. Number 4, the measure of an interior angle. There we go. The measure of an interior angle of a polygon, regular polygon, is 174. So again, keywords here, we've got regular polygon, interior angle. Name that polygon. 2 big ways to do this. One is to go straight to the interior angles, right? Because this is all about interior angles. The interior angle of polygon is going to be n minus 2 times 180. That's the sum of the interior angles divided by n, and that should equal 174. This sets up an equation that it's not easy, but it's not a wildly difficult equation to solve. I would multiply both sides by n, distribute the 180, and that would give us 180n minus 360 equals 174n. And now it looks like a much more solvable equation. Nothing wrong with doing it this way. However, if you think about this backwards and say, okay, if the interior angle is 174, that means the exterior angle is 6 degrees. It needs to be supplementary. And since we just did on the previous problem, that 6 degrees needs to go into 360 an even number of times. It's going to go in 60 times. And so 360 divided by 6 gives me an answer of 60 sides. If I solve this equation, I'm going to get the same thing, because I'm going to subtract that 174. It gives me 6n, add the 360, and divide by 6. Number 5. What is the measure of one interior angle for a regular hexagon? All right, this is the one where we kind of depend on our vocabulary coming through. We need to really think. And remember that a hexagon has, has 6 sides. So when we talk about regular hexagon, we're talking about 6 sides. So n equals 6 is my little regular reminder. And now I'm going to go through and I'm going to use this formula. 6 minus 2 times 180 divided by 6. There we go. And see what that equals. We've got 4 times 180. And then I'm going to take that answer divided by 6 and I end up with 120. Again, here we can definitely talk about exterior angles and say, okay, 360 divided by 6, same thing here. We end up with 60 degrees for each exterior angle, and if the exterior angle is 60, then the interior angle must be 120. Both ways are fantastic. Number 6, find the measure of the marked angle. The marked angle is x right down here. The polygons are regular polygons. So over here we've got a regular pentagon because we've got 5 sides. So I might quickly say, okay, so 5 sides, that means 3 times 180 is this and that divided by 5, 108. So each of these angles is 108. And then the other shape is an octagon, 1, 2, 3, 4, 5, 6, 7, 8. Octagon, so again, quickly here, we've got octagon is 8, so not 5, 6 times 180. And take that answer divided by the 8 sides, and we end up with 135, so 135 degrees. If we look at specifically these 3 angles, 1, 2, and then our unknown 3, those should be 360 degrees. They make that full circle. And so I know that 108 plus 135 plus x should equal 360. And so I could just take that 360, subtract 135, and also subtract the 108. And that gives me 117. So x equals 117 degrees. All right. Number 7, the angles of a pentagon are 10x, blah, 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 blah. Okay. Pentagon, 5 sides. I can go back over here to my work because I've already done this. 540 is what that pentagon adds up to. And so 10x plus 12x plus 1 plus 5x plus 6 plus 11x plus 16 plus 137. All of those together should equal 540. If I'm doing my math correctly, I gotta combine my like terms. So I've got my x's. Let's see. 10x, 12x is 22, 27, 38 x's. And then we've got 1, 7, 23, 23, 160. 160 equals 540. I'm going to subtract 160 on both sides. Love to say I'm going to do this in my head, but it has been a day. So I'm going to go ahead and lean on that calculator a little bit. We end up with 380 equals 38x. Oh, I can do this one in my head though. X equals 10. Again, don't be fooled into thinking just because you solved x, you've got the answer to the question. The question is, what is the smallest angle? I can throw away the 12x plus 1, that one looks pretty big. So I'm going to go to that 5x plus 6. 5 times 10 is 50, plus 6, 56 degrees. All right, that takes care of day 1.